Ever wonder what it really takes to build a world-class large language model from the ground up? I mean, not the theory, but the actual in-the-trenches secrets? Well, today we're cracking open the Smol Training Playbook. It's basically a guide that spills all the painful lessons and hard-won wisdom from the teams building giants like Llama 3 and Qwen. And it all kicks off with one simple question most people just skip right over.
Right. Before you write a single line of code or spin up a single GPU, the playbook slams on the brakes and asks the most important question of all. Should you even be training this model? Seriously, it's a strategic gut check that could literally save you millions of dollars and months of headaches.
So, how do you answer a question that big? Well, you need what the playbook calls a training compass. This is your guide for making that make or break decision. Do you build from scratch? Or is there a much easier way?
The playbook lays this out in a super clear flowchart. And here's the key takeaway. Training a model from scratch should be your absolute final last resort. First, see if an existing model can do the job. If the answer is no, okay, try fine-tuning one. Only if both of those fail do you even begin to consider the massive undertaking of pre-training. And if you get to that point, you've got 3 different paths you can take.
Path number 1 is all about research. Your goal here isn't to ship a product. Nope. It's to answer a very specific scientific question. Like, hey, can this new optimizer I came up with actually scale to 10 billion parameters? Or can a model learn to reason just from reinforcement learning? The hypothesis comes first. Path 2 is production. This is for when the off-the-shelf models just aren't going to cut it. Maybe your data is super specialized. Think complex legal contracts or dense scientific papers with their own language. Or maybe you're working in a regulated field like finance or healthcare, and you need absolute total control over your training data for safety and compliance reasons. And the third path? That's strategic open source. This is where you look at the whole AI landscape and you spot a hole. You say, you know what's missing? Maybe there aren't any good small models that can handle a giant million-token context window. Or maybe all the big models are kind of terrible at a language that you happen to have a ton of data for. The goal here is to build something that adds real, unique value for the entire community. Okay, so you've walked the flowchart, you've picked your path, and you're all in. It's time to build. The next step is to draw up your model's blueprint. This is where you make those huge foundational choices about its architecture, and this is critical, its data. This chart is so revealing. We hear all this buzz about the attention mechanism in transformers, right? Well, take a look at the anatomy of a typical 1 billion parameter model. The attention layers, they're actually one of the smallest pieces of the puzzle. The real heavyweight, making up over 65% of the model's parameters, is the feed-forward layers. It just goes to show how crucial those big architectural decisions really are. So at a high level, you've really got 2 main flavors to choose from. You've got your classic dense transformers. They're the stable, well-understood workhorses. Then you have mixture of experts, or MO. This architecture lets you scale your parameter count way up. But, and this is a big but, it's a lot more complicated to train. So it's a classic trade-off between power, complexity, and what you can actually afford to build. Now, let's talk about a piece of the puzzle that is so often overlooked but is absolutely vital. The playbook calls the tokenizer the unsung hero of a model's performance. This is the little engine that turns our human language into numbers the model can process. And if you get this part wrong, you can cripple your model before you even start. Just get a load of this example. Using a tokenizer that's not really built for multiple languages, a simple English sentence gets broken into 20 tokens. Makes sense. But the exact same sentence in Arabic, it just explodes into 122 tokens. That is wild. It means every single thing you do with Arabic text, training, inference, you name it, is now over 6 times more expensive and 6 times slower. Now watch this. Switch to a properly trained multilingual tokenizer, and that same Arabic sentence is now just 44 tokens. That's a nearly 3x improvement in efficiency, so the takeaway is huge. Your tokenizer isn't just a minor detail, it's a core strategic decision that impacts your budget, your speed, and your model's performance. So we've got the compass and the blueprint. But what's the real philosophy here? What's the secret sauce that separates the teams that win from, well, everyone else? It's this, right here. The teams that excel in LLM training are the ones that are obsessed with high-quality data more than anything else.
It's not about chasing the newest, fanciest architecture. It's about a relentless, almost fanatical obsession with curating the data that you feed your model.
The playbook boils this winning formula down to 3 things. 1. Iteration speed. You got to build a new model every few months, because the fastest way to learn is by doing. 2. That data obsession we just talked about. And 3, and this one might surprise you, small teams. You don't need an army of engineers. The playbook claims a focused team of just 2 or 3 people can train a model on the scale of Llama 3 today.
But even with the perfect formula, let's be real, training is a marathon. It is a grueling, months-long slog where things will inevitably go wrong in the weirdest ways. The playbook shares some incredible war stories from the front lines.
For example, during one training run, the team ran into a terrifying mystery. Just hours after kicking things off, their training speed, the throughput, suddenly fell off a cliff. A training run that was supposed to take a month was suddenly on track to take 2, just burning cash every second.
So what was the culprit? Some catastrophic hardware failure? Nope. It was a tiny, subtle bug in how random numbers were being seeded across the different GPUs. Because of this one little error, half of the model's weights were basically garbage from the very beginning, poisoning the entire training run from step 0.
The lesson they learned is just so powerful. In their words, be paranoid. Test every single change, no matter how small you think it is. Because having that systematic, paranoid validation process is what allowed them to find this needle-in-a-haystack bug in a single day, instead of wasting weeks.
So, you've survived the marathon. You debugged the nightmare scenarios. You finally have a base model. You're done, right? Well, not quite. The journey isn't over. Now you've got to go beyond the base model.
Think of it like this. Pre-training is like forging a massive, powerful engine. It's got all this raw potential. But post-training, that's where you build the rest of the car. That's where you use things like fine-tuning and preference optimization to teach the model how to be helpful, how to follow instructions, and how to align with what we humans actually want.
And that brings us right back around to the beginning. The secrets from the Smol Training Playbook, they're out there now. It's a map, a compass, a collection of hard-won lessons. So the final question isn't just about how to build a model, it's about why. Looking out at the whole landscape, what's the gap that you are going to fill?